Our model is a wireless charger. Wireless charging, also known as induction charging, uses an electromagnetic field to transfer energy between two objects. Energy is sent through an inductive coupling to an electrical device, which can then use that energy to charge batteries or run the device. Our wireless charger uses an induction coil to create an alternating electromagnetic field from within a charging base station, and a second induction coil in the portable device takes power from the electromagnetic field and converts it back into electrical current to charge the battery. The two induction coils in proximity combine to form an electrical transformer. Greater distances between sender and receiver coils can be achieved when the inductive charging system uses resonant inductive coupling.
These are the components that we use: 2 circuit boards, 2 MOSFETs, 2 2UF capacitors, 2 470 ohm resistors, 2 10k ohm resistors, 2 ultra fast diodes, 2 12 volt Zener diodes, 1 ferrite toroid, 1 USB female cord, 1 bridge rectifier, 1 3300 UF capacitor, 1 fixed voltage regulator, 2 18k ohm resistor, 2 12k ohm resistor, copper wires, and 14 gauge wires. The power source is supplying voltage of 12 volts and a current of 2 amperes. The circuit acts as an electronic oscillator and converts the direct current from the power supply to an alternating current. The alternating current flow in the transmitting coil produces a magnetic field, which is picked up by the receiving coil. This is electromagnetism in action. The magnetic field induces an alternating current in the receiving coil, and this process is known as electromagnetic induction. The alternating current at the receiving end passes through the bridge rectifier and is converted into direct current. We use a multimeter to pinpoint the error in our circuit when our model failed to work. By the low voltage flowing through a particular point in the circuit, we were able to determine that error was related to that particular point, and thus this helped us to significantly reduce the time and effort spent in pinpointing errors to be rectified.
Electromagnetism. Electromagnetism is the production of a magnetic field by varying current flowing in a conductor. When wires are coiled, the magnetic fields of each part of the wire are in the same direction and are confined to a small area, therefore producing a stronger magnetic field. Electromagnetic induction. Current is produced in the conductor when it is placed in a varying magnetic field, because the magnetic lines of force are applying a force on the free electrons in the conductor and causing them to move. The process of generating current in the conductor by placing the current in the changing magnetic field is called electromagnetic induction. If an AC current is fed through the coil, the electromagnetic field produced is minded in all directions. It is constantly growing and shrinking due to the constantly changing current in the wire. This oscillating magnetic field can induce electrical current in another coil that is brought in range of the first coil. The magnetic field can pass easily through solid objects. The current in the second coil will also be AC, and in fact will look very similar to that flowing in the first coil.
A transformer utilizes the two principles of electromagnetism and electromagnetic induction. The ideal transformer induces secondary voltage as a proportion of the primary voltage, and respective winding turns as given by the equation. According to this formalism, when the number of turns in the primary coil is greater than the number of turns in the secondary coil, the secondary voltage is smaller than the primary voltage, and vice versa. Resonance. Resonant inductive coupling, or electrodynamic induction, is the near-field wireless transmission of electrical energy between two coils. They are tuned to resonate at the same frequency. The equipment to do this is sometimes called a resonant or resonance transformer. Resonant transfer works by making a coil ring with an oscillating current. This generates an oscillating magnetic field. Because the coil is highly resonant, any energy placed in the coil dies away relatively slowly over very many cycles. But if a second coil is brought near it, the coil can pick up most of the energy before it is lost, even if it is some distance away.
Wireless charger, eliminating the need to have the wires, is more convenient. With a battery-powered power source, it can be portable and provide electricity anytime, anywhere. The use of universal serial bus terminal is beneficial, as all USB devices will be compatible with this wireless charger. Therefore, gadgets such as USB fan will work with our model. Handphones such as Nexus 7 also have integrated wireless charging capability. These are some other associated benefits of wireless chargers.